All right, we will go ahead and get started. Good morning, everyone, and welcome to a Southeastern Caribbean Disaster Resilience Partnership Resilience in Action Forum. My name is Claire McGrath, and I am the director of SCDRP. So you might have noticed, if you've been around for a little while, that we are changing the names of our regular webinars from partnership meetings to resilience in action forums. So we changed the title to make it clear that anyone is welcome to attend and participate in these forums. It's not just for SCDRP members, although we do welcome you to join us as a member. So if you haven't already, please feel free to drop your name, affiliation, and location into the chat so we can get an idea of who's joining us today. So to start off, as usual, I would like to acknowledge and thank our benefactors and partners. So thank you to the Indian River Lagoon National Estuary Program and the NOAA Southeastern Caribbean Regional Collaboration Team, or CCART, for serving as benefactors of SCDRP. We are also grateful to our sustaining and supporting partners, IEM, Moffitt and Nichol, and Georgia Tech Center for Sustainable Communities, Research, and Education. SCDRP is a part of SCORA, the Southeast Coastal Ocean Observing Regional Association, which is a 501c3 nonprofit organization. And if you want to learn more about SCORA, if you're not familiar, visit scora.org. So moving forward, at the beginning of each of our forums, we will have a few minutes for you all to share funding announcements, job opportunities, events, collaboration invitations, or other regional updates. You can either unmute yourself to share or drop your announcements into the chat. I'm going to start us off with a few SCDRP and regional announcements. And heads up that I have a lot of QR codes coming up, so get your phones ready if you're interested, but these will also all be in our newsletter tomorrow. So if you're not signed up for our newsletter, head over to our website, scdrp.scora.org, and you can sign up for it right on our homepage. So first off, applications are now open for the 2026 Heat Tabletop Exercise Design Challenge, hosted by the National Integrated Heat Health Information System at the NOAA Office of Oceanic and Atmospheric Research Climate Programs Office. The challenge invites community leaders to design situation manuals for heat tabletop exercises, which test local heat response efforts through simulated scenarios. Up to 40 communities will win a $25,000 prize, and the application deadline is August 12th. Next up, a great hurricane season resource. So ahead of peak hurricane season, NOAA is sharing their Southeastern Caribbean Disaster Guide, accessible in both English and Spanish at the QR code on the screen. This guide contains information, resources, and points of contact from NOAA that can support disaster preparedness, response, and recovery in the region. If you have any questions, reach out to Alyssa Zabrowski. I think she's on here today with NOAA's Disaster Preparedness Program at the email on the slide.
This conference will be recorded.
You're turning off your, there we go, muting yourself if you are not speaking. So next up, SCDRP is thrilled to release Stronger Together, Partnerships, Capacity, and Collective Action. This report and action plan is a culmination of the discussions and ideas shared at the Emergency Management Roundtable held in Charleston on March 6th, 2026. As extreme weather is intensifying across our region, this report is intended to serve as a resource for the Southeastern Caribbean region and beyond. It illustrates how to strengthen local emergency management capacity, particularly in under-resourced jurisdictions. This report focuses on leveraging collaborative partnerships. Creative funding strategies was a big topic of conversation at the roundtable, and collective mobilization, such as building trust networks before an event happens. It offers key insights on capacity and funding challenges facing emergency managers, ideas for cultivating non traditional partnerships, and priority action items, as well as some sample frameworks for implementation. So, emergency managers are the primary audience of this report, but it's also equally relevant to organizations working alongside them in disaster preparedness, response, recovery, and mitigation, as well as funding organizations, multi sector practitioners, and researchers in the resilience field, and non traditional partners such as faith based organizations, academic institutions, retail partners, credit unions, you name it. You can access the report on our website, scdrp.socorro.org, or at the QR code on the slide. And keep an eye out for more announcements. We'll try to do a report release webinar sometime in the next couple of months to share a little bit more. All right, last announcement. July is a busy month for SCDRP. On July 9th, we have a rescheduled presentation from Dr. Ashley Ward on navigating climate resilience policy in today's political environment. She'll go over tips on how to talk to policymakers and align incentives. On July 23rd, we will have a panel discussion on sargassum, the Southeastern Caribbean's emerging disaster. We're extending this forum by a half hour because we have a great lineup of multiple expert panelists. To stay updated and sign up for our webinars, you can head over to our website, again, scdrp.socorro.org. You can follow us on our LinkedIn or sign up for our newsletter. All of the announcements that you just heard will also be in our newsletter, which will be sent out tomorrow. So next up, I'd invite anyone who has any announcements to feel free to raise your hand and unmute yourself or drop them in the chat. And just a reminder that you can also share opportunities through the Collaboration Hub. This is a simple form where you can submit your resources to share. That's where I got several of the announcements that I just shared. You can share training opportunities, requests, and we will share those announcements out through our webinars, social media, newsletter, and website. Yeah, Gary.
Yeah, quickly here. Morning, Gary Harris, Managing Director, Center for Sustainable Communities. In Hampton Roads, Virginia, we're going to have a trifecta of events around community coastal resilience. First, we're bringing together over 17 emergency managers at NASA to have a day-long workshop along with communities, members, and community leaders, elected officials, and a host of others. Again, talking about the region's emergency management preparedness as it relates to sea level rise, and also the 10th anniversary of Hurricane Matthew and such. So we'll be looking at the present day effects in terms of sea level rise and tidal surges occurring during storm events, and laying on top of that, Hurricane Matthew. Again, in the present day sense, with all those other cumulative impacts. And the following day, we'll be having something called Rally for Resilience. In 2017, we won People's Award for having this program on in Southwest Atlanta, when we bring together a host of stakeholders and partners and such, and marry them up primarily with youth to get them engaged in this field around resilience and sustainability, as well as as well as emergency management. So we'll be having hourly the character from NOAA, as well as a host of emergency managers and again stakeholders across the board in this ecosystem related to emergency management. And then the next day, we'll be having a town hall meeting. Where again we'll go over the exercises and workshops we did in the prior days of the week and such, and allow others, including community members, to chime in again what it's going to take to make our community more resilient. Also, we'll be doing a hazard mitigation planning analysis, et cetera, et cetera. So 3 full days of action as it relates to resilience, as it relates to Hampton Roads and its challenges when it comes to uh, these things in our space around emergency management.
Awesome. Thanks, Gary. If there's a website or anything that you can direct people to, feel free to drop it in the chat or just email it to me and I'll share it in our newsletter. That's
Absolutely.
exciting stuff.
Yeah.
Wonderful. Anyone else before I introduce our speaker for today? All right, feel free to drop any additional announcements in the chat. All right, without further ado, I am pleased to introduce Dr. Dongmin Kim, our presenter for today. Dr. Kim is an assistant scientist at the University of Miami's Cooperative Institute for Marine and Atmospheric Studies, working in collaboration with NOAA's Atlantic Oceanographic and Meteorological Laboratory. Dr. Kim earned his PhD in Urban and Environmental Engineering from UNIST in 2017. Prior to his current position, he held postdoc research roles at the University of Miami and at UNIST and was a visiting scientist at the NASA Goddard Space Flight Center. He is the lead principal investigator on the Climate and Ecosystem Fishery Initiative project funded by NOAA. Dr. Kim has authored or co-authored 37 peer-reviewed publications in journals and has received several awards, including the Korean Meteorological Society's Best PhD Dissertation Award and recognitions from the University of Miami and NOAA. So, Dr. Kim, thank you so much for joining us today. I will make you a presenter now. All right, you should be able to share your screen and I will hand things over to you.
Can you guys see my presentation?
Yes, we can see it.
Okay. Thank you, Cleo, for giving me this great opportunity to share our research with everyone here. So, my name is Dongmin Kim. I'm an assistant scientist at the University of Miami CIMAS, and I'm also working at the NOAA AOMAN. Actually, I'm interested in the ocean and atmospheric interaction and their impact on the extreme weather events such as hurricane, tornado, flood, drought, and heat waves. So today, I will talk about the answer and its impact on the hurricane activity, focusing on the Caribbean and Southeast US. Before jumping into the main talk, I'd like to introduce our laboratory, AOMAN, and our extreme weather team. The Atlantic Oceanographic and Meteorological Laboratory has two cooperation institutes, CIMAS at University of Miami and NGI at Mississippi State University. And AOMAN has three divisions, uh, Hurricane Research Division and Physical Oceanography Division and Ocean Chemistry and Ecosystem Division. I belong to Physical Oceanography Division, and our division has four main research themes. Uh, the ocean observing system and meridional overturning circulation and observation for blue economy and extreme weather. So I'm mainly involved in this meridional overturning circulation and extreme weather research. And here is the AOML or Ocean and Extreme Weather team. So we are working on the impact of the climate variability on the extreme weather events listed here. And also we are explore, exploring the impact of the data simulation and ocean observing system on the forecast speed for the extreme weather event. And our team has spent a lot of time improving the forecast speed for extreme weather events. And we also are collaborating with other OAR labs for improving the forecast speed of the hurricane and tornado activity. Let's move on to the today's main talk. So what is the answer? I think most of you are already familiar with the answer. The answer is usually means both El Nino and La Nina together. So El Nino is characterized by the warmer sea surface temperature (SST) than the climatological average in the equatorial Pacific, like during the 1997 boreal winter. And La Nina is opposite. Unusually cold SST appear in the equatorial Pacific, as seen in the 1998 boreal winter. So these events are warm or cold SST anomaly greater than zero point 0.5 Celsius above or below the climatological value. And this answer is a coupled ocean and atmospheric process with a 2 to 5 year cycle, which is why we said answer is on annual climate variability. And please look at this time and longitude diagram showing the SST anomaly during the El Nino and La Nina years. So answers typically develop during the boreal summer season and peak in the winter season and dissipated the following the spring. So why is answer important? Because answer influence the weather and climate around the world. So as shown in the previous slide, answer has a strong seasonality, which means that it impacts people between the boreal summer and winter. So, for instance, during the boreal summer, El Nino needed to generate a cold and dry condition over the Indonesia and eastern Australia. Conversely, during the La Nina, the warm and wet conditions typically occur in the same area. And how about the boreal winter time? So during the El Nino, the warm SST in the equatorial Pacific increased the precipitation in this region and decreased precipitation in the western Pacific warm pool area. And through the atmospheric teleconnection, temperature also leads to increase in the Korea and Japan and southern Australia. During the La Nina, this phenomena are reversed. The colder SST decreased precipitation in the equatorial Pacific and increased the precipitation in the western Pacific warm pool. So now let's zoom in on this figure for to focus on the North America. The impact of the answer on the southeast U.S. is driven by extratropical teleconnection. Specifically, during the El Nino, wet and cold conditions develop over the southeast U.S. Due to the extended Pacific jet stream. In contrast, during the La Nina, northward shifted Pacific jet stream leads to warm and dry conditions over the southeast U.S. And the answer modulate the atmospheric circulation not only through the extratropical teleconnection, but also through the tropical water circulation, like this. So during the El Nino, the enhanced convection in the central tropical Pacific leads to suppression of the convection over the Caribbean Sea. Conversely, during the La Nina, convection over the Caribbean Sea is enhanced due to the changing in the water circulation. So, as a result of this water circulation changing, the Caribbean is usually warm and dry during the El Nino, but cool, it is cool and wet during the La Nina. So this graph illustrates the precipitation in the Puerto Rico during the answer years and neutral years. As shown in here, Puerto Rico precipitation decreased dramatically during the El Nino year and increased during the La Nina year compared to the neutral year. And ENSO can influence not only temperature and precipitation in the US and Caribbean, but also other extreme weather events. For example, during the El Nino, tornado outbreak in the US tended to decrease. During the La Nina, however, they tended to increase, uh, especially over the southeast US and Ohio Valley. In case of the Atlantic hurricane, also produced the unfavorable condition for the hurricane genesis. For example, also increased the vertical wind shear over the Caribbean Sea and Gulf of America, and also increased the atmospheric stability and decreased the low level rotation flow. So, less major hurricane developed during the El Nino compared to the La Nina. So, this result suggests that ENSO can be a good predictor for Atlantic hurricane activity. From now, I will briefly introduce some of our teamwork regarding the ENSO and Atlantic hurricane. At first, our team explored the relationship between the global SST and Atlantic hurricane activity. This last figure shows that uh, during the entire hurricane season, the SST anomaly over the Niño 3 area and the SST over the main developed region are highly correlated with the uh, accumulated cyclonic energy A, which is a proxy for the hurricane activity. This ACE is hurricane proxy data calculated by the integrating the shared wind speed of the hurricane over their lifetime. So we broke this down into the early season and late season. So in the early season, the negative signal in the answer area disappear, but the MDR positive signal still remain. However, during the late season, the answer region SST shows a significant negative correlation with the Atlantic Hurricane A, so which means that warm answer SST decreased the Atlantic Hurricane activity. So this research suggests that building a seasonal forecast model using the only answer index or only the MDR index are limited. So we developed the intervention SST index, which shows difference between the answer SST and MDR SST. So we built a Atlantic Hurricane seasonal forecast model using the intervention SST index. The black line indicates the observed as A's, and the red line indicates the reconstructed A's using the intervention SST. So it shows about the 0.6 correlation coefficient, which means it has a reliable prediction scheme. But actually, since the official outlook, no outlook use a probability forecast metric, we developed a probabilistic forecast model for the Atlantic hurricane activity using the dynamic forecast model output. So we validate our probability forecast model using the received operating the characteristic curve, ROC curve. This ROC curve is combination of the heat rate and the false alarm rate of the hurricane activity. So if forecast line are located in this red area, the model forecast speed is worse than telemetrical forecast. However, if forecast line are located in this blue area, it means that the model outperformed the telemetrical forecast. So as you can see that all models has a full prediction skill for the near normal region, but during the late season, both above normal and below normal forecast shows a good probability forecast scheme. However, in the early season, the prediction skill for the below normal activity is relatively weaker compared to the late season. This is because the relationship between the ENSO and Atlantic hurricane is weaker during the early season, and also the ENSO variability is usually stronger during the late season compared to the early season. So using the developed forecast model, our team has been participating in the NOAA seasonal outlook discussion. So NOAA officially announced a nationwide Atlantic hurricane outlook every year. I think you guys are very familiar with this pie graph. So in 2025, NOAA successfully forecast uh, Atlantic hurricane season. So it was slightly above normal. So, however, if you look at the 2025 hurricane track map, most of the hurricanes travel over the open sea, and just two very weak hurricanes reach to the U.S. and Mexico. So even though the 2025 hurricane season was officially above normal, kind of we were feeling like it was below normal. So this suggests that even though the current nationwide outlook provide very good information about the hurricane for hurricane, but it does um, have a regional hurricane information. It means that it can't tell us where we will actually be affected by the hurricane. So improved, we have improved our forecast model to forecast sub-basin hurricane activity to overcome the limitation of the basin-wide forecast. So we broke down the entire basin into these five sub-basins. So this figure shows the correlation of the age between each basin in the observation. So as you can see that Atlantic hurricane activity is not highly correlated across the sub-basin. So for example, the Caribbean age is correlate with the Gulf of Gulf of America age. However, the relationship between the Caribbean and subtropical North Atlantic is not significant. So it means that each basin has its own characteristic linked to the SS pattern and other hurricane conditions. So the light panel shows that a partial correlation between the ACE and each basin and the global SST. So we found that the Caribbean ACE is negatively correlated with an El Nino region SST. So it suggests that ANSO is a major contributor to Caribbean Sea hurricane activity. So based on these results, we have developed a sub-basin hurricane forecast model. Yep. This is the model result. The correlation between the observed and reconstructed heat ice using the dynamical model SAT of statistically significant in the all five observations, especially Caribbean. Uh, Caribbean shows the highest correlation coefficient among the observations. And we also validate probability forecasting speed across the five observations. So as you can see, all ratings shows a reliable forecast speed for both below and above normal hurricane activity. So this updated forecast model now participated in the NOAA official seasonal hurricane outlook discussion. And I'd like to slightly shift gear to the Atlantic Ocean. Similar to the answer, Atlantic also has a periodic warm and cold SST oscillation in the eastern equatorial Atlantic. So we called it the Atlantic Niño and Niña. So this figure illustrated the 2021 Atlantic Niño event. This time longitude map shows the warm SST developing in the May and dissipating the after November. Actually, the Atlantic Niño usually peaks in the Korea summer. So, Atlantic Niño can influence the Atlantic IPCG and precipitation around the Western Sahel area. Uh, However, Atlantic Niño also modulates the Atlantic hurricane, especially uh, Cape Verde hurricane, which form in the deep tropics and near the West Africa. So this figure shows the partial regression of the Atlantic Niño on the hurricane activity and answer on the hurricane activity. So in contrast to the answer during the Atlantic Niño, the hurricane generated east of the 40 west increase and producing the increase in the hurricane track density into the Caribbean and Florida. The physical mechanism is that the Atlantic Niño enhanced the Atlantic IPCG and African easterly wave and low-level rotational wind, which are favorable conditions for hurricane development in the deep tropics and near the Cape Verde Islands. So why this Cape Verde hurricane are important? This color in this figure illustrates the major hurricane genesis. So you can find that most of the major hurricanes generated in the deep tropics and near the Cape Verde Island. So these hurricanes generated here have a more chance of becoming the major hurricane due to their longer travel time over the ocean to allow them accumulating the heat and moisture from the ocean. So the Atlantic Nino and Nina have a greater impact, greater impact on the major hurricane than Enso. So this that result is shown in this bar graph. And in the previous presentation part, we discussed the current state of the Enso and its impact. Now, I'd like to briefly discuss how will Enso change and its impact on the Southeast US in the future. So in this time series, red, blue, and green lines of observation of the ENSO standard deviation, and the gray and black line from the climate prediction model. So consistent with the observation, the prediction model shows the increasing trend in the ENSO standard deviation during the historical and future period. And addition in this figure, Uh, this figure indicates the ENSO related precipitation in the historical and future period and difference between them. So look at this figure, the precipitation over the southeast US and Western US are projected to increase in the future. And this right figure shows the standard deviation of the ENSO-related precipitation and residual precipitation, which means that total precipitation minus ENSO precipitation. So the residual precipitation variability is slightly increasing in the future. However, the ENSO-related precipitation variability is largely increasing in the future, especially Southeast US and Western US. So these figures suggest that the swing of the flood and drought occurrence in the Southeast US are projected to increase due to the increase in the ENSO variability. So now we look at the future changes in the Atlantic hurricane. So this left figure shows the future changes in the variability of the particular wind shear and repeated index and SST, which are a critical variable for Atlantic hurricane activity. So as you can see that the variability of all three variables are projected to increase, especially in the Caribbean Sea. So this means that the year-to-year oscillation of these variable will be larger in the future than in the historical period. So this light panel shows the time series of the occurrence of the total age. The red bar indicates the above normal season, and blue bar indicates the below normal season, and the green bar indicates the near normal season. And this PDF illustrates the probability of the each total in the future. So due to the enhanced internal variation of the answer, as I mentioned in the previous slide, and also enhance the MDR SST. So due to these factor, both active and inactive hurricane season is projected to increase in the future. However, the near normal season are projected to decrease. So this uh, uh, this result suggests that in the future we could experience the strong swing between the active and inactive hurricane season. Okay, let's return to the present 2026. From this thing, many media announced that we might experience a super El Nino this year. So this is from the CNN, and this is one of the articles from the Nature. So by definition, a strong El Nino means that SST anomaly exceeds 2 degrees Celsius. So based on the CPC forecast it's in the May, there is no chance of the La Nina developing this year, and the probability of the neutral year disappear from this summer, dropping the below 10%. And this figure is from the AOML Hurricane Forecast Outlook. So it shows the SST anomaly prediction from the dynamic forecast model. So as you can see that the equatorial Pacific is project to warm significantly, rising from the 1.7 degree in June to 3.0 degree in the November. So based on the answer forecast from the CPC and a dynamic forecast model, a strong El Nino is expected this year. So since El Nino is expected, NOAA officially announced that the 2026 Atlantic hurricane season is expected to be a below normal season, showing a 55% chance of the below normal. There was only 10% chance of the above normal season and 35% chance of the near normal season. So, since the CPC and dynamic model forecast expect a strong El Nino to develop this summer, I'd like to look at how this strong El Nino will affect this year hurricane activity in the southeast US and Caribbean. So this map shows the spatial pattern of the Atlantic hurricane activity during the moderate El Nino year versus strong El Nino year. So the overall pattern are very similar between two, but the strong El Nino composite shows a much more pronounced signal over the Caribbean and uh, south southeast US. So in summary, we can expect very suppressed hurricane activity this year across the Caribbean and southeastern US. Yeah, I think this is the maybe last slide. Thanks for your attention.
Thank you so much, Dongmin. Um, yeah, I see we already have one question in the chat. So please feel free to drop your questions into the chat or raise your hands. Really interesting. I think especially the future forecasts of Enzo and how it's going to lead to more extremes and like these bigger swings of below normal and above normal and less normal. I think is super interesting. So we have one question in the chat so far. Does this research account for rapid intensification that we have experienced with two recent events in North Carolina? Tropical storm Chantal and Hurricane Helene. So can you talk a little bit about like rapid intensification and how that fits into all of this?
Actually, in in the presentation, the study in the presentation is did not mention and about the rapid intensification, but one of our study so that during the in the future we have got a more rapid intensification near the coastal area. So yeah.
Thank you. Another question. Is there any research to forecast El Nino and La Nina events in the next 20 to 30 year time frame? So kind of zooming in.
Yeah, we have some more near term near future project projection of the answer. So look at this graph. You can find that in the near future, the answer, the standard deviation of the answer is very, it's getting stronger. So it means that the La Nina and the super El Nino and super La Nina can be uh, more often occur in the near future based on the results from the prediction model.
Thank you.
So yeah, this paper is one of the kind of that research.
Yeah, and share the will you share the link to your to this paper
Okay.
either with me or in the chat? And so I can share your paper with along with the recording. And a couple other comments and questions. Oh, thank you. Perfect. From Karen, and I agree, it was interesting to see how the experience of hurricanes on land in the US and Mexico didn't really correlate with the overall activity. So, and I remember this too, living in Florida, this above normal year for 2025 actually felt pretty quiet.
Yeah. So
Um, yeah, if you have anything to
yeah, actually the most of the my friends always ask me you are working at the NOAA, so but you guys announced that 2000, 2025 it it could be the above normal, but there is no hurricane came into the Florida or something like that. So every time I told them we are successfully forecasting, it was above normal. But the the most of the hurricane is just travel into the open ocean. So that is why we try to develop this sub-basin forecast system.
Mm-hmm. Yeah, absolutely. And we have another question. Can we expect more drought conditions in El Nino years?
Yes, in the southeast area,
In the southeast, yes.
southeast, yeah, this area because of due to the answer.
Mm-hmm. I have a question, and this is for you. And also, I know we've got a couple of NOAA folks on here, so I'm going to also put the NOAA folks on the spot um, to see if you can weigh in as well. So I know you showed those pie graphs where NOAA predicts the normal, above normal seasons, and you shared how if you look at the longer range forecast, we're going to have fewer normal seasons. It's going to be either above normal or below normal. Is there any point that NOAA would change kind of where the standard for normal changes as ENSO intensifies?
Um,
Yes,
yeah, yeah.
I can tackle that question. Hello, this is Josme Lopez. I work closely with Dongmin here at NOAA AOML, and we're part of the official team that builds this outlook every year. And we
Mm.
always come up with that question. The the way we define seasons is based on historical data, and ever since 1995, we've been experiencing a very active, or more active than normal hurricane season. In fact, for the past 20 hurricane seasons, there's been only a very few um, normal validated seasons. So the question is, do we change the way we measure what normal is? Or and that question is tied to whether the changes in the statistics are natural or external. Natural meaning, are we in a above normal type of period, and then we're going to have some sort of reversion to the mean? If that's the case, we shouldn't touch the statistics. If this is part of a underlying trend, then the statistic has to be adjusted. So the question is, are which one is which? Are we is the natural cycles dominating the recent periods, or is it an external factor? And the final answer to that is still not that clear, because while we have seen impacts of climate change, uh, the natural component is also very strong, especially for hurricanes. So we don't want to be moving the bar either left or right, depending on the fact that this may be natural. But the statistics are based on historicals, and yeah, they're kind of like out of phase right now. But I agree that assuming that future projections are correct, if we see more swings, active and inactive, then that means we'll have to adjust those thresholds of what an active and inactive season will be like in order for us to forecast terciles, like one third, one third, one third equally.
Interesting. Thank you. Couple more questions. Does this from Kamiko, are the heat waves that Europe is experiencing related to ENSO activity?
Uh, Actually, I don't think so. And so I think that this Europe uh, heat wave in the Europe is more related to the North Atlantic Oscillation (NAO) or AMO in the Atlantic multi-decade oscillation. I think. Yeah.
Thank you.
Yeah.
Yeah,
Yeah.
I'll briefly answer that one too. ENSO teleconnections towards the northern hemisphere is the strongest later in the year. We have a developing El Nino now, but the atmospheric tunnel that will allow for something in the tropical Pacific to influence as far as Europe is present more later in the year, in the fall and winter time. So ENSO teleconnection tends to be around this year, around this time of the year and late summer is more towards the southern hemisphere. So probably the heat wave that we have seen in Western Europe is either driven by internal atmospheric dynamics or something outside ENSO teleconnections.
Right. That makes sense. Thank you. And I think we've got time for one or two more questions. I see one more question from Kamiko. And this question could also be for either you, Dongmin, or any other NOAA folks on the call, or anyone else who has a perspective on this. What work is being done, or maybe should be done, to embed these predictions into state and local disaster planning? So basically, it's a big question, I know. So how should local, state, and local planners be preparing? And maybe it's a big question. So maybe specifically for this, yeah, Alyssa, I see. Alyssa, feel free to jump in if you have a great answer. Maybe specifically for, you touched on this super El Nino. It's all over the news. Everyone is talking about it. And you mentioned that there is a strong possibility. The predictions are showing that there will be a strong El Nino this year. So for those people who are emergency managers or making decisions for their communities, what should they prepare for this year? And again, anyone who wants to jump in, because I know this is a big question. And Alyssa, I might, since you popped up in the chat, I might pick on you for this to see if you have a perspective as a representative from NOAA's disaster preparedness program.
Yeah, I'm over here trying to think of the best answer to try to cover this in relation to the presentation, right? So my expertise is not, I'm a very generalist scientist. So I know a little bit about a lot of things. And I think one of the things we can continue to do as scientists is that communication piece. So when we're working with folks that don't, regularly study the atmosphere and the oceans, it's just communicating what our agency, broader NOAA is doing and taking those key messages and translating those to things that make sense. In terms of this year, I mean, that's tough, right? Because it's you see below normal prediction and you kind of go, phew, but it's something we always say, it only takes one storm, right? So I don't think that we should prepare any less because of a below normal season. And that's something I try to communicate with people is, we prepare as if, as normal. So I don't know, it's a tough question. I think, and especially this year too, a lot of, administrative policies are changing. So that's something we also are preparing for is when something happens, the processes that we normally rely on for funding and for recovery and response, they're changing a little bit. Mm-hmm. So there's a lot of things, and it's a big question to answer. But I think in terms of this presentation and something we can learn from Dongmin is like or something that I learned today is, you know, there's a lot that we can't, we're still learning in terms of ENSO, and what we were just saying is it's hard to differentiate between what's normal and natural versus what is happening because of external factors. And I'm still learning too. Admittedly, I'm relatively new at NOAA, 2.5 years in, so I'm still learning a lot of the ins and outs of this. And so that's a long-winded way of saying it's a hard question to answer. And, you know, I think all of us
Yeah.
have very different perspectives.
Yeah, thank you for letting me put you on the spot. And I think it's a great answer to a tricky question. And I think, like you mentioned, that science communication, science translation piece is key. And, you know, it's important that members of the public know about Dongmin's research and kind of the why behind why we're seeing some of these swings. Because I do think about in the future predictions, when we're seeing these wild swings, you know, I could see people getting a little complacent in the below normal years, and then you're hit with a really above normal year. So I think understanding the science behind these swings and finding a way to translate this for the general public is really important. And I think, you know, that's why everyone is here today, to learn more about kind of the why behind and the research, what the research is telling us, so that we can then bring it back to our communities. So with that, we are at 11 o'clock. Dongmin, thank you again so much for presenting today. And we will share this recording on our YouTube channel and email it out to all of our newsletter subscribers as well. So thank you again so much for joining us and for a great presentation.